Long before anyone talked about parts per million or safety limits, tuna simply counted as food. Coastal communities caught it because it was there, because it was filling, and because it travelled well when dried, salted, or cooked soon after landing. People judged quality with their senses and experience. How fresh it looked, how it smelled, how it tasted. The ocean felt endless. What came from it felt trustworthy. Tuna earned a special place because it delivered more than a meal. It meant reliable protein for families and crews, and it supported local trade wherever boats could reach schooling fish. The important numbers were practical ones: the size of the catch, the weather window, the price at the dock. No one asked what invisible chemicals might have followed that fish through its life. That question did not exist in everyday thinking. So tuna stayed allowed without anyone needing to allow it. There were no tests, no warning labels, no agencies comparing risks. The sea was treated as a natural system that cleaned itself, and a predator fish like tuna was treated as a prize, not a problem. That belief carried real consequences later. But here, in this earlier era, the story moved on with simple confidence. Catch it, cook it, eat it. In the 1800s and into the 1900s, industry expanded fast. Mines, metal processing, chemical plants, and coal burning all used mercury or released it as waste. It did not stay put. It rode smoke, it washed off sites, and it flowed into rivers. At first, it looked like just another byproduct of progress, but the scale changed. So did the consequences. Scientists began to notice something unsettling. Mercury showed up downstream from factories, then in sediments, then in the animals living there. Early tests were crude, but patterns appeared. Waterways near industrial centres carried more contamination than remote ones. This was a shift in thinking. Pollution was not only a local mess on land, it moved through water and it entered living bodies. As researchers sampled fish and other marine life, the implication became hard to ignore. What left a smokestack or a drain could later turn up in a meal. That idea landed with force because it connected two worlds people kept separate: industrial waste and everyday food. Mercury stopped being an abstract chemical. It became something that could travel quietly, build up over time, and reach the dinner table. By the middle of the 20th century, mercury stopped being just an industrial chemical on paper and became a human emergency. In Japan, the fishing community around Minamata started suffering strange, crippling illnesses. Families ate seafood as they always had, then lost coordination, speech, and control of their bodies. The cause took time to accept because the poison did not come in a bottle. It arrived through dinner. Investigators eventually traced the damage to methylmercury, a form that moved easily into living tissue and hit the brain hard. It built up in fish and shellfish, then concentrated again in the people who depended on them. The scale of the harm forced a shift. Governments treated methylmercury as a major health hazard, not a distant pollution issue. One disaster made the risk undeniable, and it demanded a public response. That response turned into rules and routine measurement. Officials started formal monitoring of seafood and waterways, and they pushed industries to control discharges that could create methylmercury in the first place. Standards and enforcement did not appear overnight, but the direction changed. From then on, mercury in food became something that got tracked, tested, and regulated. After Minamata, ignorance no longer looked like an option. Researchers faced a puzzle. Mercury showed up in many fish, but the numbers did not stay even across the sea. Small fish carried some. Bigger fish often carried much more. It looked unfair, almost random, until scientists followed mercury through the food chain. They learned it did not just spread out and disappear. It built up, step by step, as one animal ate another. In the water, mercury changed into a form that living things absorbed easily. Tiny organisms took it in first. Then small fish ate thousands of those organisms, keeping the mercury their bodies could not break down or remove quickly. Next came larger hunters that ate many small fish. Each meal added a little more, and almost none left. Concentrations rose as the chain climbed. That process had a name: biomagnification. That new idea finally explained tuna. Tuna lived long lives, grew large, and fed high on the food chain. A single adult could have eaten an enormous number of contaminated prey over years. The mercury did not arrive in one dramatic dose. It arrived in countless small ones. Time turned those small doses into a heavy load. The top predators ended up with the highest levels, simply because they sat at the top. Canned tuna moved from a niche product to an everyday staple. It travelled farther, lasted longer, and reached more kitchens than fresh fish ever did. That success created a problem regulators could not ignore. If mercury built up in big predators, then a food eaten weekly by millions needed a clear rule. The question stopped being, did tuna contain mercury? It became, how much was acceptable? So governments built a new kind of standard, a legal limit for mercury in fish. Not a warning, a number. Labs tested samples, and the results got compared to a threshold written into policy. Below the line, the product stayed on the market. Above it, it failed. This shifted the whole debate. Tuna did not have to be mercury-free to be sold. It only had to be under the limit. That boundary made tuna allowed, but it also quietly defined what safety meant. The limit did not promise zero risk for every person, every serving, every week. It promised control. It let regulators manage a mass-market food without banning it, and it gave industry a target to meet. From then on, mercury turned into a compliance issue. Tuna stayed in pantries because it passed tests often enough to fit inside the rules. Once legal limits existed, a new problem surfaced. The rules answered what stores could sell, but not what families should eat. Mercury did not affect everyone the same way. A typical adult handled occasional exposure differently than a developing brain. Health agencies faced a choice. A simple warning like avoid tuna sounded safe, but it also pushed people away from an affordable, familiar protein. So the message changed from a ban to a calculation. Agencies focused on the groups with the least margin for error. Pregnant people, those trying to get pregnant, nursing parents, and young children. Guidance started revolving around risk, not fear. It separated the hazard from the dose. Small amounts could fit. Too much, too often created unnecessary risk, especially during early development. That shift produced a practical rule for consumers. People still ate tuna, but they watched portions and timing. They picked lower mercury options more often and treated higher mercury choices as occasional. Weekly limits appeared, written in everyday language, built around body size and life stage. The goal stayed consistent. Reduce exposure where it mattered most, while keeping tuna on the table in safer amounts. At first, tuna had been treated like one big category. A can was a can, and the rules had applied broadly. But the data kept showing something awkward. Not all tuna carried the same mercury load. Different species grew at different speeds, lived different lengths, and fed at different levels in the food chain. That meant risk shifted, even when the label still said simply tuna. So the market and the regulators had started splitting tuna into types people could actually recognize. Light tuna had been positioned as the lower mercury choice more often, while albacore had carried higher levels more often. Then the breakdown went further, species by species, because even light had not meant one fish. The category decided the risk, and the risk started deciding the advice. That separation changed what safe sounded like. Guidance had not been a single yes or no anymore. It had become a set of lanes. Some tuna had been steered toward everyday meals. Other tuna had been pushed into smaller portions and fewer servings, especially for pregnancy and children. Labels and recommendations had followed the categories, and consumers had been asked to choose tuna the way they chose a dosage. As tuna turned into a truly global product, the way it got watched changed. Fish caught far offshore moved through brokers, processors, and canneries, then crossed borders by the container. That scale demanded a new kind of control. Testing programs expanded beyond occasional spot checks. Routine sampling became part of the pipeline, built into processing plants, ports, and market surveillance. The goal stayed simple: keep most tuna moving, but verify it stayed under the legal limit. Import controls tightened that system. Shipments got held, paperwork got reviewed, and selected lots got sampled before they ever reached store shelves. Labs measured mercury and compared results to the threshold that decided what counted as allowed. Most batches passed because suppliers learned what buyers and regulators rejected, but the system never promised perfection. It promised detection. When a result came back too high, that lot stopped moving, even if the rest of the shipment continued. Then came the pressure test. Recalls. They happened when monitoring, audits, or later retail sampling linked a batch to levels above the limit. Products got pulled, distributors got alerted, and the trail of codes on cans mattered. That response protected the shelves from the worst outliers without banning tuna outright. It also created a quiet trade-off. Tuna stayed widely available because enforcement focused on removing failing lots, not eliminating an entire food. Scientists had learned to measure mercury, and they had learned to limit it. But they also faced a practical question. What happened when a food carried some risk and real value at the same time? Tuna did not just deliver calories, it delivered dense protein that helped people feel full and stay nourished. So researchers stopped treating the decision as a simple yes or no. They treated it as a trade-off that needed numbers. That trade-off sharpened when nutrition entered the mercury conversation. Tuna carried omega-3 fats that supported the heart and the brain, the kind of nutrients many diets lacked. It also contained selenium, a mineral that interacted with mercury in the body and appeared to soften some harm, even if it did not erase it. The picture became less dramatic but more realistic. Risk depended on dose, and benefit did too. So the modern argument shifted from fear to balance. For most adults, the expected benefit of eating tuna in sensible amounts outweighed the expected harm from the mercury levels that stayed under legal limits. The danger concentrated in the same places agencies had warned about before: frequent servings, bigger tuna types, pregnancy, and small children. Continued allowance did not mean mercury had vanished. It meant the net calculation usually landed on benefit. Tuna stayed allowed because it never became a single yes or no decision. It became a managed risk. Different countries set legal limits, and those limits decided what could be sold. Testing and paperwork backed that up, even when the rules varied from place to place. So tuna kept moving through markets, not because mercury vanished, but because most batches stayed under the line. But that line never meant the same thing for everyone. Advisories filled the gap. Guidance targeted the people mercury harmed most, and it pushed a new habit, choosing tuna by type and by frequency. 1 can a week did not equal 1 can a day. Tuna stopped being one product, and it became a set of choices with different risk levels. That was the trade-off modern rules accepted. The system allowed tuna to stay on shelves while warnings and limits tried to steer exposure down. It asked shoppers to think in data, not tradition. Read the label, switch species, watch portions, especially for pregnancy and children. The old trust from Chapter 1 faded, replaced by measured permission.